Jai Hind, Vande Mataram. This is Kunal Mehta from Make Me Scientific, and in this video we are going to understand the graphical representation of the standing waves which are produced by the superposition of incident and the reflected waves on a string, but one end of the string is fixed. So over here I have just shown that there is a pulse or a transverse wave having amplitude A. Now this is going in positive x direction. Now this wave hits the fixed end. So this is the equation of the incident wave, y is equal to a sin omega t minus kx, because it is going in plus x direction. So after the reflection there is a phase reversal of pi. So the crest becomes the trough and goes in the negative x direction. So there is an addition of phase pi, and over here the minus sign which was here becomes the plus. Okay, so it anyhow becomes minus a sin omega t plus kx. So we will remember this equation and this equation. Now quick recap of four graphs. Y is equal to sin theta, crest always at the top and the trough at the bottom, minus sin theta, the trough comes first and then the crest, plus cos theta, this is plus cos theta graph, it starts from the positive y axis and ends into positive y axis. In the same way, if this is minus cos theta, then it starts the opposite way from the negative part and ends into the negative part. Now since we are discussing about the closed end part or the fixed end part, always understand that a node is going to be created at the fixed end, because there has to be no displacement. So now let's find out the shape of the resultant wave, and let's graphically represent both the waves at time is equal to 0. So at time is equal to 0, incident wave is equal to a sin omega t minus kx. So the incident wave becomes a sin, since the time is 0, it will reduce to minus of kx. So the incident wave is equal to minus of a sin kx, that is due to the fact that sine of minus theta is equal to minus sin theta. Now in the same way, the reflected wave equation was minus a sin omega t plus kx. So I am going to substitute time 0 over here. So the reflected wave equation becomes minus a sin kx. If you look at these two waves, they are in phase, so they are going to constructively interfere with one another. So if I plot a common graph for both of them, I will have to draw at least two waves. Minus of sine function, this is a plus a on the top, minus a on the top, a amplitude, and if you need not to worry about this a part, but minus of sine function means it starts like this. This is my one graph. Actually it should be almost looking the same like this, and then the second like this one. This is the equation of the incident wave, but since the reflected wave is also the same, so I am going to draw it by the red dotted line. Same amplitude, same frequency, everything is the same, constructive interference, and the red one is the reflected wave. So you will get double the amplitude of the resultant wave. So the blue color wave is the resultant wave, and finally you will get it like this. This is the resultant wave, right? Now these points where crest and crest of both of them they meet, they are antinodes. This is antinode, this is antinode, this point is node, this is antinode. Again over here between two antinodes you will have nodes, nodes, nodes like this. So this is the graph at time is equal to 0 for all the three waves. Now let's go ahead and write the equations for time is equal to t by 4. The incident wave is a sin omega t minus kx. We do know the fact that omega is 2 pi by t times, here I am going to substitute time as t by 4 minus of kx. So what is going to happen? T gets cancelled. Here it becomes yi. The incident wave becomes equal to a sin pi by 2 minus of kx. So this is incident wave equation. A sin 90 minus theta is equal to plus cos theta. So plus sine turns into cos times kx. Let's look at the reflected wave equation, that is a minus a sine omega t plus kx. Now I am going to substitute 2 pi by t by 4 plus kx. Again this will be minus a sine 2 gets cancelled tt. So this is pi by 2 plus kx. Now sine 90 plus theta is in the second quadrant. So what's going to happen? This sine gets converted into cos. In second quadrant cos is positive, so plus into minus is minus a cos kx. This is the equation for the reflected wave. You can see that they are out of phase. So when they interfere, destructive interference is going to happen. So let's plot both the graphs together for the incident one. Since it is plus cos function starts from here. This is one wave and then the another wave. So the black one is the incident wave. Now let's draw the reflected wave, that is minus of cos function. So minus of cos function is just the opposite of the plus cos function. So like this. So everywhere where you have crest and trough becomes the node, this is node, fixed end is always node. At all the areas in between two nodes, points in between two nodes are the antinodes. In this way you will get a very flat string at time is equal to t by 4, because due to destructive interference the string will remain flat. So this is what is expected at time is equal to the string ray stays flat at time is equal to t by 4. Let's repeat the same thing at time t by 2. So yi is equal to a sine, this is omega, that is 2 pi by t, times omega t is t by 2 minus of kx. Now the reflected wave is a sine 2 pi by t times t by 2 plus the kx. So the incident wave becomes a sine, this 2 gets cancelled, tt gets cancelled, so this is pi minus kx. Here the reflected wave, sorry I missed out minus sign, this is minus a sine pi plus kx. So what's going to happen here? The incident wave is a sine pi minus kx is in the second quadrant, and in second quadrant sine is positive and the sine remains sine function when we have pi. So like this. The reflected wave equation is minus a sine pi plus theta is in the third quadrant, sine is negative, so that minus, this minus becomes plus. So you can see that constructive interference is going to happen. Now if I plot both of them, both are positive sine function. So positive sine function like this, and then the another wave like this. This is my incident wave, and the reflected wave is also the same, but I will draw with red color just a dotted line, and wherever the crest and crest meets you will have double the crest, trough and trough meets double the trough, so you will have double the amplitude of the wave like this. Alright, so this was the red one was reflected and this is the resultant wave. So crest and crest meeting antinode, trough and trough meeting antinodes. So these are all the regions of antinodes. Between two antinodes you must have node, the fixed end is always the node. So this is the entire story for time is equal to t by 2. Okay, so this one was the third one. Now we will go ahead, yeah I guess it was the third one. Now let's go ahead with the fourth part, wherein I am supposed to plug in the value of time as 3t by 4, and let's write down the incident wave equation, that is a sine omega is 2 pi by t times small t, that is 3t by 4 minus of kx. Reflected wave is again minus a sine omega, that is 2 pi by t times 3t by 4 plus kx. So the incident wave is equal to a sine 2 gets cancelled, tt gets cancelled, this is 3 pi by 2 minus kx, and here the reflected wave is minus of a sine 3 pi by 2 plus kx. Now guys, in both the cases yi, the sine 3 pi by 2 minus theta, where this theta is less than 90, falls into the third quadrant. Sine 3 pi by 2, when you have 3 pi by 2, pi by 2, 5 pi by 2, 7 pi by 2, sine gets converted into cos. Anyhow, the angle is falling in the third quadrant, 270 minus theta, so it has to be minus of kx. Now yr is equal to minus of a sine 3 pi by 2 plus theta falls in fourth quadrant, and the sine becomes cos, so I should be writing this as cos function, and minus of this minus becomes plus, right, and kx. So what's going to happen? You look at both of them, they are out of phase, destructive interference. So if I plot the graph, minus of cos function is, this is one curve, the second. This is my incident wave, and let's talk about the reflected wave. The reflected wave is plus the cos function, so like this. I'm sorry, could not draw the very perfect diagram. The amplitudes of all of these loops must be the same. So this is my reflected wave, and these are the areas node, anyhow two fixed ends are the nodes, crest and trough meeting node, node, node. In between two you have antinode, antinode, antinode and antinode. The string is going to remain the flat at this moment. Now I would appreciate if you solve for time is equal to capital T, the fifth one by yourself, and if you have any doubts related to this video, please do comment in the comment section. I only feel one thing about the viewers is they are a little bit confused in this sine pi plus theta, pi minus theta, like that. So for that you please check out the basic maths, and I hope you might have understood this well. Any doubts, please do comment. Thank you for watching the video.